Okay, so pendulum back and forth 30 times in 2 minutes. What's the length of the pendulum? So I got pendulum going back and forth. It goes back and forth, 30 times in 2 minutes. So 30 oscillations. 2 minutes is 120 seconds. And then I want to know what the length is. Okay, so the period for a pendulum, the only equation is this. Period is equal to 2 pi squared root of L over G. G I know is 9.8. L is what I'm solving for, so all that's easy enough. Here's where the period gets tricky. So the temptation is to say, oh, it's 2 for 2 minutes. Well, it has to be in seconds. And I try not to do that kind of tricky stuff to you on the final. So then it's like, oh, well, it's 120 seconds. Well, that's the time to go back and forth 30, not the time to go back and forth once. Period is the time it takes to go back and forth once. Has to be the time to go back and forth once. So, in order to get the period, I have to do what period is. Period is time per wave. So, time per oscillation gives me 4. That's the period. Okay, here's how I like to solve this. I like to turn 2 pi into 6.28. Now, I really use the full multiplied out thing, but you can use 6.28. Your rounding will be slightly different than mine, but not significantly. Okay, I'm going to divide that to both sides. Get that 6.28 away from there. Okay, so 4 divided by 6.28, going to be 0.64. And all I'm left with over here is square root of L over 9.8. Right, that 6.28 is gone. Now, I got to get rid of the square root, so I'm going to square both sides. And the reason I'm doing that is squaring gets rid of square rooting. So I'm going to square the 0.64. That's going to give me 0.40. And I got rid of the square root, so now it's just L over 9.8. Multiply the 9.8 to both sides. And I get the length to be 3.97 meters. Be careful on this one. The algebra is tricky. When y'all solve this, like a lot of people had the right idea but had trouble with the math. Show as much work as you can on this one. I find that it's easy to skip steps, and then if you do, you kind of wind up in trouble usually. Okay, any questions on that one? All right, you're done with 6 of the problems, so